Okay, so let's take a look at our TI calculator and let's remember how to clear the memory. So we go second, 0, 2, and we've cleared the memory. Now, just like with univariate data, we're going to insert our data using the data key. So click data. Now, because we're working with bivariate data, we're going to have list 1 and list 2. List 1 is going to represent our X values and list 2 is going to represent our Y. So they will be ordered pairs. So I'm going to enter my ordered pairs of our data of how many hours. So someone studied 2 hours, 6 hours, 6 hours, 5 hours, 3 hours. Someone else studied 3 hours, 2 hours, 1, 4 hours, 4 hours, 0 hours, 3 hours. Someone studied 5, 1.5 hours, and 4.5 hours. Now, we have to be super careful when we enter our Y values in list 2 to make sure it matches up with that X value. So the person that scored or studied for 2 scored a 75. So our output are the scores, our inputs are the hours. Then we have a 95, 92, 94, 82, 86. Then we have 78, 71 for somebody that studied 1 hour. We have a 94, a score of 90, a score of 60 who studied 0 hours, a 79, a 98, a 74, and lastly a 90. So I just make sure that all of my X's and Y's from list 1 and list 2 line up. Now we can find our line of best fit. So we are, again, just like with univariate, we're going to go to second stat, but this time instead of 1 variable stats, we're going to go to 2 variable because we're working with 2 variables. Then our X data is in list 1, our Y data is in list 2, and then we want to calculate. Now this is going to give us all that we need. So again, we can see that the average hours of study is 3.3. We're going to scroll on down, and we are looking for the little a. So see where we have the big D. Okay, so that's line D. The little a is going to be your slope for your line of best fit. So we will probably always round to the 10th unless otherwise noted. So we have an a value of 5.6. That will be your slope, your m in slope intercept form, with a y-intercept of 65 point, and we will just round that to 65.1. We may even round it to 65. So that is your line of best fit. Now, while we're here, let's go ahead and just look at the next line down, that line F. That little r is your correlation coefficient. We will talk about that in just a few minutes, but I will tell you that value lets us know how strong our line of best fit is. Does that equation y equals 5.6x plus 65, does that represent our data points really well, strongly, or not? And so again, A is your slope, B is your y-intercept, and R is your correlation coefficient.